In a major leap forward for battlefield drone technology, the U.S. Defense Advanced Research Projects Agency, DARPA, announced on June 17, 2025, that 5 innovative vertical takeoff and landing, VTOL, unmanned aerial systems, UAS, will begin flight trials before the end of the month. Each platform weighs under 150 kilograms and is part of DARPA's early VTOL aircraft demonstration, EVADE, project, a key phase within the broader ancillary initiative, Advanced Aircraft Infrastructure-less Launch and Recovery, which is designed to provide flexible air power independent of traditional runways or airfields. The goal of EVADE is not to deliver a finished product out of the gate, but rather to test and refine forward-looking drone capabilities faster than traditional development paths allow. By fast-tracking testing that was originally scheduled for late 2026, DARPA is embracing a more agile model, one that prioritizes speed, risk-tolerant experimentation, and field adaptability over initial perfection. Early performance benchmarks show that the new systems surpass current VTOL drones in terms of flight duration, range, and flight control. All 5 aerial vehicles operate with Matrix, a suite of autonomous flight software developed through DARPA's earlier Alias program. This autonomy stack allows the drones to carry out entire missions with minimal human oversight, from takeoff to landing. Additionally, integration with the Tactical Assault Kit, TAK, through the Naval Surface Warfare Center Dahlgren Division's Battle Management Interface allows real-time communication with soldiers on the ground, eliminating the need for bulky control centers and reducing overhead. The drones, built by AeroVironment, Griffin Aerospace, Karam Aircraft, Method Aeronautics, and Sikorsky, are engineered for a variety of field tasks. These range from aerial resupply and comms relay to precision strikes, reconnaissance, and synthetic aperture radar scanning. Each drone is designed to deliver a 27-kilogram payload over a distance of 100 nautical miles and remain airborne for a minimum of 12 hours, giving small units access to sustained, multi-role aerial support previously limited to much larger platforms. Beyond the technology itself, the ancillary program is laying the groundwork for a rapid response manufacturing pipeline capable of scaling production quickly. Efforts are already underway to handle regulatory certification, assembly logistics, and lifecycle support, aiming to ease integration into military operations. The long-term vision includes enabling non-aviation combat units to deploy and operate these drones independently, a major potential shift in how air assets are utilized across the U.S. Department of Defense. DARPA expects these systems to be transitioned to active U.S. military units by the end of 2025. With its emphasis on modularity, resilience, and quick iteration, the EVADE/ancillary development strategy is poised to significantly increase tactical air capability at the squad and platoon level, even in environments where traditional air support is unavailable.